So for number 2, here's how I want you to now kind of do this. Rewrite this equation, x squared minus 12x, and then put plus, and then put a blank right here for right now. Then put the little plus 4 that we actually have in our problem. All right, from there now, if we, try to do this area idea, this one, again, these should not be congruent. They should not match up good. If we try to make this a perfect square, wouldn't this have to be x and x, which is x squared? That's all right, Sally. If we're going to do the negative 12x and it's a perfect square like we're wanting it to be, we have to put a negative 6 and a negative 6 right there. So that means each side would have gotten decreased by 6. So real quick, write down what we should get here in this 4th box, bottom right-hand corner box. Compare that to what we actually have. All right. And we should notice that those obviously are not going to be the same. So that negative 6 and the negative 6 gives us a 36. We wanted it to be a positive 4. So for us to make this perfect square, what we should have is x squared minus 12x plus 36. So put that 36 into that blank. Then, remember how we fixed all of these? Remember how we then said whatever number was hanging out at the end, whatever we just got in this lower right-hand corner, don't we just subtract that away from that constant? We would do minus 36 at the end. So now the way this is going to look, we would have y equals, if I now take, so I'm just going to rewrite all of this as one expression. This is our perfect square trinomial. This is our box to the right. That is simply x minus 6. Uh-oh. I'm not sure how I did that. There we go. So let me get rid of this. So the x minus a 6 squared. And then we now would end up with a negative 32 on the back. All right. Once we do that, we know our vertex is a positive 6, negative 32. We know our axis of symmetry would have to be the vertical line x equals 6. Let's draw a quick little sketch of this guy. So 6 is here, negative 32 would be way down here. So we're way down here in the 4th quadrant. The number in front of our x squareds are all positive 1s, so that means our parabola opens upwards. So domain-wise, we haven't done one problem yet with these parabolas where our domain is not a negative infinity to infinity. So that's still going to be the case. And then our range is the smallest y value to the largest y value. So if we look at this vertex here, the smallest y value we would have hit is this negative 32. And we go up forever. So negative 32 with a bracket to infinity is our answer. All right. Now, moving forward, this is how I want you to kind of set these up. And it's because we're going to have to make an adjustment to what's happening here in this next page. And it really kind of starts playing with your heads a little bit. Okay, so what I mean now in number 3, what I'm going to have you do again is we're going to rewrite this as y equals x squared minus 10x. And then just like that quiz, I'm going to have you fill in the blank of what would have made that a perfect square. So pretend right now, so don't cross this out on yours. Do not cross that out on yours. But on the quiz, I gave you one of these. We did a number of these in class. Put whatever value would need to go here so that we make this a perfect square. All right, so now, hopefully, if we're going to just write this as a perfect square, this is our whole, we're going to cut this in half. That's going to give me a -5. That means each side has a -5. They would have gotten multiplied by each other to give us a 25. All right. So that's if we just had these two guys, but we don't. What we still had hanging out at the end was that -9. So just like we have been doing, since I've added a 25 in here, what we've said we have to do to figure out the back end is subtract whatever number is. So we're going to do -25 on the back side. So that if we now write this here as a perfect square, what we would have had is x minus 5 twice. So x minus 5 quantity squared. And then we would have had a -34 for the y coordinate of our vertex. All right. Now, vertex, all that, we're going to move along to number 4. I'm going to do one more together, and then I'm going to make one up and see if we can kind of do this with how I'm showing you how to do this. So just jump to number 4. If we can get to this, I'm going to trust we can do most of the stuff below it. And with our shortened periods this year, we need to kind of expedite some things. So go to number 4. Do x squared plus 6x, and then complete that square. All right, so just basically treat that as its own problem, and then our poor little 17 we're going to ignore for a second. He's going to hang out at the end. All right, these we're pretty good at. You're cutting this 6 in half to get a 3. Each side would have been increased by 3. So that lower right-hand corner would have been a 3 times a 3. So if we want to make that a perfect square, that should have been a +9. But what we have is a 17. So the way we said we've been able to figure out what our y coordinate is whatever that should have been, we just subtract away from what we actually have. So while we're adding 9 inside, you're going to subtract 9 on the outside. So what this now becomes would have been this x plus 3 2 times that. And we now know the y coordinate is an 8. So that we could say our vertex is a -3, +8. All right, so real quick, add a 5 at the bottom of this paper. And let's say I gave you this, x squared plus, let's do 16x plus 4. Put that into vertex form. Ooh, what just happened there? Plus 4. Try not to use your box. If you had to, you could. But try to do it the way that I'm showing you up here, where we want to complete the square. And then whatever that would require us to add, you're going to subtract away from the 4 on the end of it. All right, Cam, what'd you fill into the blank line here, Cam? Good. To make this a perfect square, we would do 64. So what that would then mean, this would have been, if we divided this by 2, we would have had an x plus an 8 on each side of our area model of the rectangle or square that we had drawn in. But if we're going to add 64 inside, what have we been doing on the outside then, Cam? Sort of. We're subtracting 64 from this guy, right? Correct. And what we end up with then for our answer is what he said. We would be subtracting 60 away. All right. Okay. Are we following this kind of same thing we've been doing? Just a little bit different way to write it that I'd like you to write it so that when we get to these problems down here, When we start throwing some numbers in front, we can kind of have a little different process to this. Okay? All right, next thing, number 6, what I want you to do before we go to this next page. Tell me this. Remember we talked about GCF? Give me the GCF between 6x squared, 4x, and let's do 2x to the 4th. Tell me what you think the GCF of that would be. All right. So greatest meaning the largest. C is your common. It has to be common to all 3 terms. And then the factor is what factor is the largest and common to all 3. So if you look at your numbers, 6, 4, 2, what is the largest number that goes into all 3 of those? 2, right? So I see some of us throwing up some 2s. 2 would go into all of those. 2 goes into itself. It goes into 4. It goes into 6. If we look at our variables, we have an x here, we have 2 x's here, we have 1 x here, we have 4 x's there. In terms of the number that is common to all of them, the only thing that's common to all of them is 1x. Okay? All right, one more, and then we'll get to really the new stuff. All right, so again, give me the GCF of, let's do 12x cubed, 6x to the 4th, and 9x squared. All right, numbers first. In terms of 12, 6, and 9, the largest number that would divide evenly into all of those should have been 3. This has 3 x's. This has 4 x's. This one has 2 x's. In terms of how many are common to all 3, there would just be 2. So 3x squared is our greatest common factor. All right. The reason we're doing this, and the reason it's going to get a little different, unfortunately, probably going to get cut off right in the middle. Every problem we've done up until this point, notice how there's a 1 in front of the x squared term. The homework the other night, you had to deal with that a little bit where there wasn't, but look here, there's a 1, there's a 1, there's a 1. So every single problem we've done so far, when we're completing these squares and doing the area model, there's a 1, there's a 1. If we look at the next page now, we're going to reintroduce these equations, but we're not going to have 1s in front of them all the time. So the stuff that we just showed you are the things that we're going to want to be able to handle when we start dealing with this. All right, so real quick, let's refresh our memory a little bit. This A, and this is the title of the section, when our A is greater than 1. Basically, it's just when A is not 1 more than anything. But right now, when A is greater than 1. Remember the effect that A has on it. It either makes it more narrow or it makes it wider, so stretched or compressed. So the first thing, we're going to graph this real quick. So go ahead and find your vertex. This is in vertex form, so that's nice. Once we have that, we can set up our XY chart. The vertex we want to put directly in the middle of the XY chart. And again, most of us did this very well yesterday on the quiz. Most of us got this one right, where I give you vertex form. You can give me the vertex, so that's good. We've made good progress on that. And then from there now, we want to pick the point directly behind it. So I'll pick a 0, and then the one in front of it would be a -2. Whatever I get here should be the thing I get right here. The point in front and behind the vertex should be the same y coordinate. All right, so we have y equals 3x plus 1 squared minus a 6. Let's take our x value of 0 and plug it in. And then we just go through these steps figuring out what our y would be. So this is 1 squared. Take away our 6. 1 squared is a 1. So we really end up with y equaling 3 minus 6, which should be a negative 3. So then we actually know both of them are negative 3s. So plot those 2 points. Let's plot the vertex first, I suppose. So that's our vertex. We just found when x is 0, y is a negative 3. And when it's a negative 2, y is a negative 3. Notice how if we draw our axis of symmetry in, those points are the same distance away from that line. So that's a good start. And then I want you to do one more. So we'll do 1 right here. So let me go back, plug in 1s now. So let the x become a 1. That would give you 2 squared. So we now have 3 times a 4 minus a 6, which is 12 minus 6. So we know we get a y coordinate of 6. So if we go to 1, 6, plot that point. If we now go back to a negative 3, we know that y coordinate would be a negative 6. Or notice how this point up here is 2 units away from our axis of symmetry. If I just go 2 units away in the opposite direction, that would have to be another point on my parabola. Okay. Notice how this guy is nice and narrow, because the bigger the number in front of our parabola, the more narrow it becomes. But what this whole section now deals with is how do we start handling this if it's not in vertex form, because it's going to change things a little bit. All right. All right, 2. This is the first time I've had you do this. What we've always been doing here the last week is I've been giving you standard form, and then you've had to put it into this form, which is our vertex form. Now you're going to do the exact opposite. This is really just some simple algebra. This is just simplifying an expression. So here's how I would recommend you do this. If I can get my eraser up. Here we go. So there's really 2 options. Well, let me see you try this. This is probably going to be where we have to finish. Simplify that for me. We basically want to multiply all that out, combine like terms. I want to see what people do with this guy. Like, how can we simplify this? Because there's 2 routes we could take, and I want to see if we remember what we did for those. All right, so whichever method you like best, totally fine. One way we can do this is to actually do 2x minus 3s. This is actually in your homework the other night where they wanted you to do this a little bit. And you would just FOIL these guys out. Remember how you would distribute, but then that negative 2 would also have to get multiplied out. We also did this as a shortcut, and that's the way I'm going to go with right now because that's the short one that I can get done in less than 2 minutes. If we look at what this is, x minus 3 squared, doesn't that just set up this area model over here, an x minus 3 on top and an x minus 3 on the side? Each of them is x minus a3. We know when we multiply those, shouldn't we get an x squared here? So I'm going to do the -2, but then I should get an x squared. We know the next term should be the sum of these guys. So that's a -6x. And then the next term should be our constant hanging out down here, which is a 9. So this here comes from us just basically eliminating the idea of a perfect square and writing it out now as a trinomial. Okay, we follow that? From there now, you're going to distribute. So take your -2. That's got to get distributed to all three of those. So -2x squared plus 12x minus 18. And then we've still got that little +1 hanging out at the end. So our final answer when we combine our like terms, the only thing we can combine now is the -18 and the 1 to give us a -17. So this is now this equation in what we would call standard form. So the trick, what we're going to have to do on Monday, because we're out of time right now, is now that this number is not going to be a 1 in front of it, how could I now take this guy and somehow then put this into vertex form? How could we work backwards from what we just did? Okay, that gets a little bit trickier. It gets a little bit harder, but that means it's probably a good time to stop right now because that's really what all these problems here are going to be dealing with. All right, you can hear the bell. Oh yeah, Wednesday. That's a good call there, Ahmed. Yeah, don't let me, I'll be here on Monday morning. Yeah, so Wednesday, we will see you guys all. So no homework. Enjoy the long weekend. Have a good little break. All right, see you guys.